This is lesson 23, part 1, and we will be discussing compound time. We have been using the Gordon rhythmic syllables as a way of vocalizing the rhythms we are practicing together and learning to read. So far, we've learned that a one-beat note is do. Multi-beat notes like 2-beat notes, 3-beat notes are just do or do. We just hold that do syllable for longer. When we start breaking beats into subdivisions or breaking beats, dividing them into smaller parts, we've talked about half-beat notes, not half notes, but half-beat notes. We've used the syllables do, day to represent our half-beat notes. And then we've used our syllables do, ta, day, ta to represent our quarter beat notes, where we've taken one beat and we've divided it into 4 equal parts. So far, we've always divided our single beats into multiples of 2. So we've evenly divided it into 2 parts or evenly divided it into 4 parts. There's another way we can divide beats. We can divide one beat, do, into 3 equal parts as well. So where each syllable is going to be worth just 1/3 of a beat. We use the syllables do, da, dee to represent our 1/3 beat. We're going to set the metronome at 60. We're grouping beats into 2, so this would be a duple time signature as we learned last time. That would be one way of classifying the time signature that we're in. And we're going to put this beat into our hands first of all. Ready, clap. Now with our mouths, we're going to say 8 one-beat notes. Ready, speak. Do, 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 do. Do it one more time and ready, go. Do, 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 do. Continuing with the metronome at 60, we're going to continue to clap our beat, our do's, but our mouth now is going to say 8 sets of 1/3 beat notes. Do, da, dee, do, da, dee, do, da, dee. Okay? Put this beat in our hands first of all. Ready, clap. Ready, speak. Do da dee, 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 do da dee. Do that one more time. Ready, speak. Do da dee, 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 do da dee. We learned that one way we can categorize time signatures is by looking at their beat pattern, or in other words, looking at how many beats per measure they contain. When we are categorizing time signatures by their beat patterns, we're going to find that we end up with duple time signatures, triple time signatures, and quadruple time signatures. In duple time signatures, quite obviously, we're going to be seeing 2 beats per measure and feeling 2 beats per measure. In triple time signatures, we can expect 3 beats per measure, and in quadruple time signatures, we can expect 4 beats per measure.
A quick review of the time signatures we looked at during our last lesson. We'll note here that in this top row, all the top numbers of the time signature consist of 2s. And those 2s tell us that there are 2 beats in each measure, so we can know that all of these time signatures, no matter what numbers on the bottom, is going to be classified as a duple time signature. Looking at this row right here, we can see that the top number of each time signature consists of a 3. That tells us that there are 3 beats in each measure. So all of these, regardless of what number's on the bottom, is going to be classified as a triple time signature or triple meter. Looking at the last row right here, we can see that all the top numbers of the time signatures are 4s, meaning there will be 4 beats in each measure. So all of these time signatures, regardless of what is going to be our beat or pulse note, all of these will be classified as quadruple meters.
Recall that another way we can categorize time signatures is by their quality. The most common qualities are known as simple time and compound time. We have almost exclusively looked at simple time examples so far. Certainly in all of our detailed practice work together, those have all been examples of simple time. In simple meters, one of the basic or undotted note values from our note value pyramid is assigned as the beat or pulse note. In simple time, we can take it at face value that if, say, the top number says 3, we can expect there to be 3 beats in each measure. And if the bottom number is a 4, the quarter note will be the beat. So we can literally count it as 1, 2, 3, 1, 2, 3, 1, 2, 3. And each of those numbers that we're saying, each beat we're feeling will literally be a quarter note beat. What defines simple time signatures is that each beat is naturally divided into 2 equal parts. All simple time signatures will have either a 2, a 3, or a 4 as their top number.
So looking at these time signatures here, we can see that they all either contain a 2, a 3, or a 4 as their top number. So already I can say these are definitely going to be examples of simple time. Let's take 2/8 time and just take a moment here to interpret the time signature. So the top number tells us there are 2 beats per measure, and the bottom number tells us that an eighth note, think of it as the denominator of a fraction, an eighth note will be our beat or pulse note. And if I were just to draw some very simple measures here, I would draw 1/8 note, 2/8 notes. I'm just filling it up with pulse or beat notes. End of the measure, draw a bar line. Another eighth note and another eighth note, draw a bar line. If I wanted to subdivide these beats or divide them into smaller note values, I could take each eighth note and I could break it into 2 equal parts, and I would be ending up with 2 16th notes. So 2/8 time is an example of a simple duple time signature because the top number is a 2, a 3, or a 4, and because each beat or pulse note naturally evenly divides into 2 equal parts.
So today we will learn about compound meters. In compound meters, the beat or pulse note is a dotted note value.
Remember that we can increase the duration of any note value from our basic or undotted note value pyramid by adding a dot to the right of the note head. For example, we can take a whole note, we can put a dot to the right of the note head, and this whole note will now be worth a whole note plus the value of the dot. The dot is worth half of whichever note it's dotting. So in this case, it would add a half note worth of duration to this whole note. A dotted half note would look like this, a dot to the right of the note head, and it would be worth a half note plus half of whatever note it's dotting, so a quarter note. A dotted quarter note would be worth a quarter note plus an eighth note. A dotted eighth note would be worth an eighth note plus a 16th note.
So we just reviewed what a dotted note value actually is. In compound meter, a dotted note value will be our beat or pulse note. I'm going to qualify that just a little bit and call it our big beat note. That is not an official term, but it's a term musicians frequently use to define the dotted note value that is felt as the big beat in compound meters. Just file that away in the back of your head. It's all going to make more sense soon. Another defining characteristic of compound meters is that because the big beat is a dotted note value, it's going to naturally evenly divide into 3 equal parts. We're going to be calling these 3 equal parts little beats. Again, this is not an official term, but it's a pretty common term that musicians use to define the 3 equal parts that all big beats are subdivided into in a compound meter. When we look at a time signature in compound meter, we cannot take it at face value. So we might see a 12 on the top, and we might see an 8 on the bottom. And what those numbers actually represent is the subdivided or little beats in each measure. So if the top number of the time signature would be a 12, it would mean there are 12 little beats in each measure. And if the bottom number would be an 8, it would mean that the subdivided beat or pulse note is an 8th note. So now that I've thoroughly confused you, we're going to look at an example.
Just like simple time signatures can be defined as simple duple, simple triple, or simple quadruple time signatures, so can compound time signatures. So compound duple, compound triple, and compound quadruple time signatures. We're actually going to work at understanding this concept by working backwards. All compound time signatures or compound meters will have a dotted note value as their pulse note or their big beat. So let's take a dotted quarter note beat, and we're going to say we're in compound triple meter. Just going to go ahead and draw 2 measures worth of compound triple meter. I need a dotted note value as my beat. So I'm going to fill each measure with 3 dotted note values. Now remember that another defining characteristic of compound meter was that each beat naturally divides into 3 equal parts. Well, how could I divide a dotted quarter note into 3 equal parts? Well, let's remember what a dotted quarter note really is. A dotted quarter note is a quarter note plus, what's the dot worth? Well, half of whatever note it's dotting, so an 8th note. How could I divide this into 3 equal parts? Well, how about a dotted quarter note equals 3/8 notes, because each quarter note is worth 2 8th notes, and then obviously this 8th note is worth itself, so 1/8 note. So I'm going to take each of these dotted quarter notes and I'm going to break it into 3 equal 8th notes. And you'll notice I'm going to beam those 3/8 notes together because we very often beam a full beat together. And now that our dotted quarter note is our beat, it makes sense to beam 3 8th notes together since we're dividing a beat into 3 equal parts. So we have 2 complete measures of compound triple meter because we have a dotted note value as our pulse or beat note or our big beat, and we have evenly divided each beat into 3 equal parts, and these are our little beats or our subdivided pulse. All we need now is a time signature. Recall that I said that the time signature in compound meter actually reflects the little beats in the measure. So what should I put as the bottom number of the time signature? Well, the bottom number tells us what kind of note value gets a beat, but in compound time, it's actually what kind of note value is this subdivided beat? Well, it's an 8th note, so I'm going to put an 8 at the bottom. And the top number of the time signature will tell us how many beats there are in a measure. Well, in this case, it's actually going to tell us how many subdivided beats there are in a measure. So how many are there? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this compound time signature, this compound triple time signature is 9/8 time.
So in compound meters, our pulse or beat note will be a dotted note value. We're going to call that our big beat. The defining characteristic of compound meter is that the big beat, the dotted note value beat, naturally divides into 3 equal parts.
In compound meter, the top number of the time signature will always be a 6, a 9, or a 12.